Do you ever look at someone and wonder what is going on inside their head?
Derivative.
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 What are derivatives? Essentially, derivatives tell us the rate of change of the function at a specific point. Think of it like this. If you're driving a car, speed is constantly changing. The derivative would tell you your continuous speed at many given moment.
To visualize its process, please watch this. Wait, that was too long. It takes too much time to do that.
Now, let's get into the meat of the matter, the derivative rules. These rules are like shortcuts that help us to find the derivative of different type of function quickly and efficiently.
Rule number 1.
The constant rule. If f of x is equals to c, where c is a constant, then f prime of x is equals to 0. Example, f of x is equals to 15, f prime of x is 0. F of x equals to 100, f prime of x is equals to 0. In Man's term, the derivative of any constant function is always 0.
Rule number 2.
F of x is equals to x raised to the power of n, where n is moved to the left side of the x and the exponent n is decreased by 1. For example, f of x is equals to x squared, wherein the derivative of x squared is equals to 2x. Another example is f of x equals to x cubed, then f prime of x equals to 3x squared.
Rule number 3.
So the next one is the constant multiple rule. The constant multiple of a function is equal to the constant times the derivative of a function. Please watch the example. Let's find the derivative of 3x to the power of 5. In this example, 3 is the constant and x to the power of 5 is the function. So let's follow the formula above. 3 is the constant times the derivative of x to the power of 5. To get the derivative of this function, let's use the previous rule, which is the power rule. The derivative of x to the power of n is equals to nx to the power of n minus 1. So the result will be 3 times 5x to the power of 5 minus 1 equals to 4.
Rule number 4.
Sum and difference rule. The sum rule and difference rule states that if f of x is equals to g of x plus h of x and the derivative of two functions g and h exists, then f prime of x is equals to g prime of x plus h prime of x. For example, f of x is equals to 3x cubed plus 2x squared. So the derivative of that function is equals to 3 times 3 is equals to 9x squared plus 4x. Another example is, let's say for example of 5x power 4 minus 3x to the power of 2. So the derivative is, as you bring down the 4, so it equals to 20. So 5 times 4 equals 20x. Then 4 minus 1, 5 minus 1 equals to 3, and copy the sign, and 3 times 2 is equals to 6x, then 2 minus 1 is equals to 1, so you don't have to put 1 there. So that is how you use the sum and difference rule.
Rule number 5.
The fifth rule is the product rule, which stated that if f of x is equals to g of x times h of x, and the derivative of two functions g and h exist, then f prime of x is equals to g of x times h prime of x plus h of x times g prime of x. In simpler terms, to find the derivative of a product of two functions, we multiply the first function by the derivative of the second function, and then add it to the second function multiplied by the derivative of the first function. To illustrate it, let's have an example. F of x is equals to 3x squared times 5x plus 2. So to calculate this, we need to find the derivative of each function. Our first function is 3x squared. By using the power rule that states that if f of x is equals to x raised to n, where n is a positive integer, then f prime of x is equals to n times x raised to n minus 1. Based on this formula, we get our first derivative, which is 6x. Then for our second function, we also use the same process. For 5x plus 2, the derivative of 5x is 5, and the derivative of 2, which is a constant, is always equal to 0. So the second derivative gives us 5. Now that we have found the derivatives of both functions, we can now apply the product rule, which states that f prime of x is equals to g of x times h prime of x plus h of x times g prime of x. Alternatively, we can use the formula u dv plus v du, or vice versa. U will become our first function and v will be our second function. Based on this, we can get f prime of x is equals to 3x squared times 5 plus 5x plus 2 times 6x. Now, we can simplify. For 3x squared times 5, we get 15x squared. For 5x plus 2 times 6x, we calculate it as 30x squared plus 12x. Finally, we combine like terms. 15x squared plus 30x squared is equals to 45x squared plus 12x. So, the derivative of f of x is equals to 3x squared plus 5x plus 2 is equals to 45x squared plus 12x. And that's the process of the product rule.
Rule number 6.
Next is the quotient rule. Quotient rule is used when you want to find the derivative of a function. That is the quotient of two other functions. It sounds complicated, but the formula is very simple. Here, f and g are our function, and we denote their derivatives as f prime and g prime. So, if you want to differentiate the function f of x divided by g of x, we follow this formula. Let's see it in action with a simple example. Suppose we have these functions. F of x equals 2x raised to the power of 2 and g of x equals x plus 1. We want to find the derivatives of f of x divided by g of x.
Number 7.
So let's proceed to the last rule, which is the chain rule. This rule is used to find the derivative of a composite function. Composite function is a function within a function. The derivative of a composite function is the derivative of the outside function times the derivative of the inside function. First, you need to identify the inside function, then the outside function, and find its derivative. Let's have this example. Let's find the derivative of x to the power of 2 minus 3x to the power of 5. This is a composite function. So you bring down the power 5, which is the power of the outside function. Then copy the inside. Now let's differentiate the inside function x squared minus 3x, which is 2x minus 3. And now we have the results.
And this you have it, the fundamental derivative rules. The best way to master these rules is to practice, practice, and practice. There are tons of resources available online, including practice problems and interactive exercise. I know it might seem like a lot to take time of this, but with constant practice and a lot bit of patience, you'll master this concept.